Hello, everyone. How are you doing? I trust you are all doing great. Yeah, it has been a while before I came your way, but boom, I'm here. James from JTS Maths Tutoring here. Today, we are going to be looking at matrices. How to add matrices, how to subtract matrices, and how to multiply matrices. And to demonstrate this concept, we have taken a question from Elementary Linear Algebra, the application versions 11th edition by Howard, Anton, and Rorres. And this question is under exercise 1.3. Suppose that A, B, C, D, and E are matrices with the following sizes. A is a 4x5, B is a 4x5, C is a 5x2, D is a 4x2, E is a 5x4. What do we mean by this? If we say A is a 4x5, that simply means A has got 4 rows and 5 columns. So when you are defining or dimensioning a matrix, we always start with the number of rows, then multiply it with the number of columns. So if we say A is an M by N, what that means is that A has got M rows and columns. All right. So determine in each of the following cases whether a product is defined or not. If it is so, then give the size of the resulting matrix. So you can actually see that this question is actually zeroing in on matrix multiplication. But obviously, before we get there, we are going to give you some notes on how to add, how to subtract, etc. Let's quickly look at that. How do you add two matrices? Two matrices A and B can only be added together if they are of the same size, or they are of the same order, or the same dimension. How is this achieved? By adding corresponding entries. And take note that order is not important since matrix addition is what? Commutative. That means A plus B is going to be equal to B plus A. So I've given you an example here. I've got matrix A with the entries A, B, C, D, and I've got matrix B with the entries E, F, G, and H. So A plus B is going to be achieved by, okay, I can see A is a 2x2, B is a 2x2. They are of the same size. Right, so I'm going to look at this first entry here, which is A, which is at the intersection of row 1 and column 1 in A. And I'm also going to look at what is that entry occupying the first position in matrix B. Right, I can see it's an E here. So that's what we mean by corresponding entries. So A plus E, B plus F, C plus G, D plus H, that is going to give us A plus B. B plus A is going to be E plus A, F plus B, G plus C, H plus D. You can tell that these two matrices, they're actually going to be equal. It's actually the same matrix at the end of the day. So to verify this, I've given you this information here. All right. Now let us look at how do we subtract matrices. Matrix subtraction, it follows the same rules as that of addition. But take note that order is important since matrix subtraction is not commutative. Just like real numbers, 3 plus 5 is equals to 8, and 5 plus 3 is equals to 8. But 3 minus 5 is going to be equal to minus 2. 5 minus 3 is going to be equal to 2. So this is exactly where we are getting that principle from. Okay, let's get going. So I've also given you an example, and I've also given you information just to verify what I've just said there. Okay, beautiful. Right, let's get going. There's what you call what scalar multiplication. So if K is any scalar, then Ka is a matrix obtained by multiplying each entry of A by K. Matrix Ka is called a scalar multiple of A. Take note, order of factors is not important because scalar multiplication of a matrix is commutative. That is, Ka is going to be equal to Ak. All right. What about matrix multiplication? So if you are given two matrices, A and B, AB is only defined if the number of columns in A, which is the first factor, is equal to the number of rows in B, the second factor. Like they say, a picture is worth more than 1,000 words. Here I've got a pictorial representation, or rather a diagrammatical representation of what I've just said above. Right? A is an M by N matrix. That means A has got M rows and N columns. B is an N times P. That is N rows and P columns. So you can see the number of columns in A, the first factor, is equal to the number of rows in B here, which is the second factor, that means AB is defined and the resulting matrix is going to be an M by P matrix. Take note, order of factors is important since matrix multiplication, it is not commutative in general. You find the cases where it's going to be commutative, and we also have got special cases where it's going to be commutative. And you're also going to find the questions whereby we are going to impose some conditions on the matrices for them to be what? To be commutative. Right, but for now, let's go and answer our given question here. All right. So just to take you back, we've got BA, AC plus D. Okay, let's look at the solution. Right. So A is a 4x5, B is a, we have already discussed that. Now you can also see now we are actually having a transpose. What is the transpose of a matrix? It's simply when you switch the rows and the columns. So what was the rows? It become the number of columns, right. For instance, you can see here that A is a 4x5, but A transpose is a 5x4. B is a 4x5, B transpose is a 5x4. D is a 4x2, D transpose is a 2x4. E is a 5x4, E transpose is a 4x5. So let's get going. The very first question, they want us to tell if BA is defined. So the number of columns in B is 5, and the number of rows in A is 4. Those two are not equal to each other. So BA is undefined. Right. Then the second question wanted us to, with this one, which I'm highlighting right here, they want us to find if AC plus D is actually defined. So the first thing is for me to get AC. So A, it's a 4x5, C, it's a 5x2. I can see that the number of columns in A is equal to the number of rows in C. So AC is actually defined, and the resulting matrix there is going to be a 4x2. Right, what is D? D is a 4x2 matrix, meaning that AC is of the same size as D. So that means AC plus D is also going to be a 4x2 matrix. Okay. And this one, which I'm highlighting right here, this one, they want us to prove right here. Okay. So A is a 4x5. ET, it's a 4x5. And this 3 is just, it's not going to change the size. It's just going to ensure that every entry of E transpose is actually scaled by a factor of 3. Okay, beautiful. So I can tell that it's still going to be a 4x5. And what is the rule of subtracting matrices? They must be of the same size. So it means A minus 3 E transpose is also going to be a 4x5. Okay, beautiful. Let's look at D here. This is what they want us to prove or to show whether is it defined. Right. So I started with BE here. B, it's a 4x5. E, it's a 5x4. So you can tell that the number of columns in B is equal to the number of rows in E. So BE is defined, and the resulting matrix is 4x4. Remember, D, it's a 4x2. So D transpose is a 2x4. And here you can actually tell the number of columns in D transpose is equal to the number of rows in BE. So that is defined, and the resulting matrix is a 2x4. All right. Let's look at this E. I'm going to highlight what they actually want us to look at right here. So they want us to prove whether B transpose multiplied by D plus ED is it defined. Okay, so BT, it's a 5x4. D, it's a 4x2. This means the number of columns in B transpose is equal to the number of rows in D. So B transpose D, it's actually a 5x2 matrix. It is defined right there. E, it's a 5x4. D, it's a 4x2. The number of columns in E is equal to the number of rows in D. So it is defined, it's a 5x2. So we wanted to prove whether this is defined. We know two matrices can only be added together if they are of the same size. So B transpose D is a 5x2 and ED is a 5x2. Then this proves that B transpose D plus ED, it is defined, and the resulting matrix is a 5x2. Beautiful. Now let us look at F. This is what they want us to prove whether it is defined or not. Okay, cool. B, it's a 4x5. A transpose is a 5x4. The number of columns in B is equal to the number of rows in A transpose. That means B, A transpose is actually defined, and it is a 4x4 matrix. Now, B A transpose is a 4x4 matrix. We know that D is a 4x2 matrix, and we want to add these two together. That is not going to be possible because we can only add the two matrices if and only if they're of the same size. So at the end of the day, we conclude that BA transpose plus D is undefined. All right, girls and boys, amigas and amigos, this is what I had for you today. Allow me to do what my mama taught me. A good visitor knows when to leave. Or mama would say a good dancer knows when to leave the dance floor. Till we meet again, be rest assured that at JTS Maths Tutoring, we are committed to keeping you mathematically informed. Till we meet again, don't do what mama and I wouldn't do. See you soon.